All right. So I wanted to tell you guys a little bit about what we used to do on the food truck at Switch It Up, because you're here to hear about the science of food gels, right? And so the food truck itself was all about basically taking food gels. We were specializing in jams, jellies, and spreads, and putting that into foods in a variety of ways. And actually, at a couple of adult nights, we brought the food truck over and started experimenting with food gels and did all sorts of different demonstrations. So we'll have a few more demonstrations for you guys later on. But I first wanted to talk about what food gels even are. So raise your hand if you've ever made like a soup stock from scratch. You know, you put all your chicken bones and your vegetables in there and you put it in the fridge to cool. What happens when you pull it out of the fridge the next day? Yeah, Caitlin. Hello, Ruth. Do you want to tell us, Ruth? Looks like you're muted.
Yeah, sorry, I'm working on an appeals letter for another fundraiser.
No problem.
I do chicken broth all the time whenever I have a chicken. I also roast beef bones to be able to make the stock, and that makes the gelatin that comes off of that is amazing. And if you've ever roasted a goose, the goose fat is the most amazing roasted potatoes ever.
Nice.
You know, that's a little bit off point, but you can also make a goose soup or a goose stock.
Yeah, and the French cooking method, the confit, is basically like cooking something in duck fat, like a solid mass of duck fat. And so
Right.
a few of you actually raised your hands and showed that, like, when you take a stock out of the fridge the first time, you have like this massive gelatin on the top of it that you have to kind of cut out. And, you know, as soon as you heat it up, it goes right back into solution. But does anybody know where that gelatin comes from?
It's the protein in the bones.
Yeah, exactly. It's collagen specifically. Yeah, Quinn's got it. And, you know, we have collagen in our bodies. It comes from the bones. And there's actually a similar substance in plants called agar, which, and Dave knows this, I'm sure. Any biologist who does molecular biology should know what agar is, because it's a very commonly used lab tool. But it's also used for foods. And so there's two different kinds of gels we're talking about here. So gelatin is a polypeptide, and agar and pectin are polysaccharides. They're still very similar in structure. They're all polymers. So think about, like, if anybody's ever done the slime experiment where you mix borax and glue together, you have this polymerization reaction that happens, and when you pull it out, you get this like stretchy, gloopy kind of disgustingness. And it's not too different from what happens with food gels, except there's not really a polymerization reaction because these things are already polymers. What happens then is, you know, after you dissolve them in solution, you know, you dissolve your agar or you dissolve your gelatin in hot water, they basically kind of like, we call it cross hatching. So they like form this like matrix in the solution, and then as it cools, they stay that way, and then you get this like really solid kind of mass. So it's why when you add like your food packet, your food powder to Jello after you've made a fresh batch of Jello, it's all watery at first, and then as it starts to cool, the gel matrix kind of stays in place, and then, you know, you get this like gelatinous thing, perfect for putting your office mate stapler inside of. There's actually one other type of food gel that I'll try and show you, and it's called sodium alginate, which is used less frequently for foods, but also is another biological lab tool. And the reason why mostly it's used less is because it's more expensive. So in terms of cost, pectin is probably the cheapest. Does anybody know where you can get pectin from?
The grocery store?
The grocery store, yeah. David, did you have one? I saw your mouth moving. You're muted.
I said the grocery store also, yeah.
Oh, okay. Yeah, you can buy pectin from the grocery store, but that pectin that you get in the grocery store actually comes from apples. So there's a few fruits that are very high pectin concentrate, and I'll let my brother talk more about that in a second. But raspberries, probably the highest, apples, probably the second highest, and they're also the cheapest, which is why they use the apples to get the pectin that we buy in the store. Gelatin, like we talked about, comes from bones, and agar comes from algae. And there's a lot of algae, especially ocean algae. And so that's where we get most of our agar from. And sodium alginate actually comes from, I think it's seaweed, some form of seaweed. And I've used this way less frequently, but it's a little bit harder to extract, and so it's a little bit more costly. So I'm going to show you a quick jam recipe before we go on to the next thing. All right, so if you were to make a very basic jam or jelly, what are kind of the steps that you would need to be able to do that?
I would do, if you're doing a no sugar added pectin, which I prefer because I can limit the amount of sugar that I add to my jams. Some pectins make you add a lot of sugar to it because there's a high amount of acid in the pectin that they have. So it's to compensate that acid flavor in there. And with the low sugar pectin, they cut back on the acid so that you can add the amount of sugar and still get your jam that you prefer.
So this is like the pectin that you can buy from the store in the packets, right?
Correct. Now, if you're doing a natural fruit without, you don't want to have to go out to the store and buy a pectin, but you want to still natural fruit jam. Citrus has natural pectin in it. Apples have natural pectin in it. Plums, peaches, raspberries, strawberries. And those you can puree up with no heat necessary and be able to make that into a jam, and it'll settle down and not be runny.
Yeah, from what I understand, the pectin that you buy in the store is actually derived from apples.
Correct.
And so you kind of mentioned a second ago the high pectin fruits. And I think, tell me if you think that there's a simpler one, but the most simple jam you can make is raspberry because you don't even need to add pectin because it's so high in pectin.
Correct. And if you ever worked with raspberry, like I've made raspberry vinaigrettes and let them sit, and they've started to do their gelatinous thing. So raspberries are the number one besides apples and peaches. Peaches are high for pectin as well.
I did not know that. Very cool. So basic raspberry jam, it's like 2 cups of raspberries, 2 cups of sugar, and a little bit of lemon juice, right?
No. That's a lot of sugar to your raspberries. I would do about a cup of sugar to 2 cups of raspberries, maybe 3 cups of raspberries, because it has its own natural pectins and it's got its own natural sugar in it. So you don't need to compensate and make it too sweet. And then if you want to add a little bit of lime juice to that, you could, but it's not necessary. And you just puree that up, or you can do a light boil on it. And then some people like it strained, some people don't. And so you just put it in your mold or your jar and let it cool.
My chemistry is a little shaky on this, but one thing I forgot to mention is that when you're using pectin, you do need an acid. So some recipes will have you add lemon juice to give that acidity that's necessary to help the pectin form the gel matrix that we talked about. One of the reasons, so going back to switch it up, one of the reasons why we liked using jams and jellies so much was because of how versatile they were cooking with. So obviously you can just make your classic jams and use them as spreads, whatever. But you could also do some other different things with them. One of the simplest things that we were able to do is turn a jam into a sorbet. You literally just like take your jam, put it in a cup, stick it in the freezer, and now you have a sorbet. And it's not too dense because the the gel kind of keeps the fruit, you know, just separated enough that it's easily scoopable. It's got the right amount of water content, a good amount of sugar content. Turned it into a really nice sorbet. One other thing that we did that was really, really simple is because it has that acidity, a lot of jams have that natural acidity, you can easily turn those into vinaigrettes. So instead of using, you know, vinegar and oil, you use your jam and an oil, just kind of mix it up, equal proportions, shake it up, whatever you need to do. And there you have your like perfect vinaigrette. So we used to make this watermelon rosemary jam, and then we do like a vinaigrette version of that. And we just take the jam, stick it with our oil, shake it up, and then serve that with our salads or, you know, whatever dishes we were preparing. Really, really good quick tip. And the third thing that my brother likes to do is turn the jams into fruit leathers. And this is also really easy to do as well, because basically all you have to do is spread your jam out onto like wax paper and dehydrate it, or you can use saran wrap, or if you have a dehydrator, some of them have like a silicone mat that you can put in there. You just like spread it into a thin layer, stick it in the dehydrator. Here in New Mexico, you could probably just, you know, stick it out in the sun and you got like sun-dried fruit leathers. And anybody who has ever, I used to do this all the time in the lab, was I'd make my agar gel and just like leave it out for 3 days, and it turned into like this fruit roll-up consistency type of thing. And that's kind of what you're looking for. So with the fruit leathers, you know, you spread it out to whatever thickness you want and let the water evaporate away. And now you have yourself a fruit leather, and really you just stop doing it whenever you get the consistency that you want. And one chef pro tip that Jason provided me before coming on here was if you have fruit slices, you can just drizzle on top right before you start the dehydration process. You could do even nuts, some nuts or berries or whatever. And then you have, you know, a fruit leather that solidifies with the stuff mixed into it. So now you have like a different texture for your fruit leathers. Really simple thing to do. The jams are super easy to make as well because they're basically purees. And sorry, Tori, there's no samples. If I was going to be evil, I would have a tray of samples right here and taste test them for you and then just say the whole time.
I bet I could find your house. You sent a picture of your backyard, so.
Yeah, we have the bar ready to go for when COVID's isolation stops. So are there any questions about what I've talked about so far, jams and jellies? And the only real difference between a jam and a jelly is the level of like pureedness. So a lot of jams they still have like whole fruit chunks in them, and jellies, you strain out the fruit. So when my brother talked about straining out the raspberries, that would become more like a jelly. The dog friend's popping on now. And one other thing about, hopefully you guys can hear me okay now. One other thing about—
Anthony, breaking out.
Yeah, I'm getting a thing that's saying my internet's a little unstable. All right, hopefully this is working. Can you guys hear me all right now? No.
Here he comes. So Anthony, we lost you. At least I did too, where Quinn said about where you were asking if we had any questions about gelling agents, and then you got lost.
I basically stopped talking at that point because I noticed everyone was saying that I was having internet issues. So is it better now? Okay, cool. So the only other thing that I wanted to mention about jams and jellies is that when you form the gel, it's actually kind of like a looser gel. So you notice that you can like pour it from one vessel to another, and it kind of flows like a really viscous material, like sort of like honey, but not quite as viscous, and it's more chunky, obviously. The next couple things that we're going to talk about, agar and gelatin, they form much more solid structures. And so, I mean, you guys have seen Jello molds, right? You can just raise your hand if you've seen Jello before. those things are like pretty solid shapes. You can shake it and do some stuff with it. Whereas if you like poured, you know, a pectin-based thing out, it would kind of just ooze into like whatever shape it is. So it's still sort of a liquid. And when you're making, so agar you can buy in the store, gelatin you can buy in the store, and it also comes in the similar to pectin as like a powder. When you're preparing dishes with this, you're preparing like a ratio. So for instance, if you have, I'm going to use the metric system because it's easiest to calculate. If you have like 500 milliliters of water and you're going to use, you know, if you want to get a 1% gel, for instance, so still gelatinous, but, you know, not super hard, you're going to use 50 grams of your gelling agent for both gelatin and for agar. And really no such ratio exists for pectin. So that's like one of the major differences. And I'll talk a little bit more about this, but I have kind of a longer video to show you about preparing a dish with agar. My brother, he did this demo where he did, so we're gonna talk a little bit about agar and gelatin, and then he makes this like mold. He uses a mold to make these heart-shaped mango and raspberry agar pieces that come out quite nice. And then he does a little demo at the end. So I'll share that with you guys right now. All right, so if you were to make a very basic jam or jelly, what are kind of the steps that you would need to be able to do? That did not play the right video.
Well, the agar ratio, like you were talking about earlier, there's 3 different kinds of agar that you can buy in a store. It's powdered agar, flaked agar, and sticked agar. But normally people see the powdered agar. And it's just a fine powder. You can buy it at any convenience store, Walmart, Publix. They all have a little container of it.
We have Smith's here, excuse me.
Sorry, Smith's, Kroger.
Come this way. Yeah, there you go.
Oops.
So that's the agar powder, right?
That's the agar powder.
And gelatin usually comes in a powder too, but you can buy it in other ways as well, or no?
Correct. If you're doing gelatin, you can do gelatin powder, gelatin sheets. And the sheets you gotta bloom first before you can mix it in with your stuff. The powder can go directly into your mixture. Make sure your mixture is hot, just like agar, and it's dissolved fully.
All right, and then so the process for both of them is kind of the same, right? You mix your liquid, basically your food base, and your gelling thing, so either your agar or your gelatin into the thing, heat it up till either of those things can dissolve, and then you cool them back down.
Correct. Typically, it's a teaspoon of agar powder to 1 cup of water, and it's a tablespoon of gelatin powder to 1 cup of water.
Mm-hmm. And I highly encourage anybody who's interested in cooking with either of these two things to look up ratio tables online, because the reason why is you'll get a different hardness of gel depending on how much of the, you know, agar or gelatin you're going to use, and different foods and different dishes have different like gel requirements. Okay, so you have a little agar station set up there, right?
Correct.
So show us what you got and walk us through your process, chef.
So here I have already placed agar. On the bottom here, I'll pop them out real quick.
Ooh.
On the bottom here is a mango-based agar. And then on top of that, I did that raspberry jam. Oops.
Slippery fish.
I did that raspberry jam that I was talking about earlier, and I used that as my top base for the mango agar cubes. This hardened up. This settled pretty quick. Probably about 30 minutes, and this thing is set.
Very cool. And so that was like after, so after you got your liquid hot, you poured it into the mold and then stuck it in the fridge or the freezer?
I did it in the freezer to speed up the process, but if you're okay with time, the fridge is perfectly fine. If you're doing layers, let the bottom layer set first, and then keep your agar stuff warm until it's set, and then you pour your second layer on it and fridge it really quick so that you have your 2 different layers inside there.
Is there a flavor difference, like between gelatin and agar?
I have not found one. Is a texture difference, but it's not. I think agar is a little bit more like a cloudy gelatin more than a clear gelatin.
Interesting. And both of them they're supposed to be flavorless. Is that right?
Correct. There's no flavor for either one of them. And I believe that agar is made from algae.
Yeah, seaweed.
Seaweed.
Yes, that's true. And gelatin comes from the collagen in bones.
Yes. You boil bones and you can make gelatin. That's why when you make stocks and your stocks start to gelatinize, it's because of the gelatin in the bones when you're boiling them.
So what do you have going on right there?
So here I got a cup of water, and I'm going to add a teaspoon of agar to this.
Whoa!
And we're just going to stir it until it is dissolved.
So it's kind of like pectin, but I think agar forms more of like a gel than pectin does. Pectin is kind of like a loose gel.
Correct. Pectin is definitely.
What were you saying? Sorry.
I would say pectin is definitely a looser gel, and it takes a lot more pectin to stiffen up than as you use agar or gel. So now once my liquid, sorry, what were you saying?
Go for it.
I say once my liquid is boiled, I'll remove it off the heat. I have my mold set up here just to show for a demonstration.
Do you cook with agar much?
I do not. Unless I have a vegetarian house.
Ah, okay. So your go-to then would be gelatin, I guess?
If I'm using, like, for cream cheese, for cheesecakes and stuff,
Yeah.
we use gelatin.
Interesting. So why not use agar for cheesecakes?
It's cheaper for gelatin.
Got it.
Agar is much more costly.
That makes a ton of sense. And
Right, I'm gonna put these in the freezer real quick.
go for it.
And let me show you the finished product of the of my agar water.
Agar, water.
Hearts. So these are.
Shake it up. What does that look like? Like, give us a little shake here. Oh yeah, that's the good stuff.
That's nice and hard, firm. But they pop out really easily.
And describe the taste and texture of this. Is just water and agar, right?
This is just water and agar. Tastes like water.
It's like hard water. I gotta try it myself, but I imagine that it's a little weird to like have the flavor of water and it be like hard and chewy.
So when I can taste the tap water, I can taste the tap water part of it, and it's just gelatinized, which is really weird.
All right, you saw it here first, folks. So Dave, you said you had a question.
I do. I was wondering if you've had to make any adjustments, you know, from when it's here in New Mexico and it's super dry versus Florida where it's super humid. Does it have any effect at all on any of the ratios, or is just not enough water to matter?
So when you're cooking with it, it doesn't really make much of a difference. The only thing that he talked about was like when you're doing fruit leathers. In Florida, because the humidity is so high, it would take like a long time, like several days to a week, to be able to dehydrate the stuff in the sunlight. So he actually has to use like a dehydrator to get that thing to dry out. But when you're actually like making the gel, it's not like baking where you have to add like extra leavening agent to get it to rise.
Does it like dry, like if you're serving it or keeping it out for entertaining, after you've made it, does the gel sort of dry out really fast?
So here it won't dry out. It'll stay pretty moist for a while, and you could keep it in the refrigerator for a few days and it should be fine. Kind of just like Jello lasts. The one thing, and I'll talk about with this sodium alginate, is this problem happens no matter what, because you need like a polymerizing agent for that. You have to like stop the reaction quickly, otherwise it tastes like really salty. And Quinn posted in the chat about tapioca, and I had thrown in their rice flour. If anyone ever has been to Banh Mi Kota, which is over in the top by Tallinn, they have this like really delicious pastry. It's like this green bread stuff, which is made mostly with rice flour. And you get this really cool texture when it comes out, where you have like a bread crust on the outside, but it looks like a gel on the inside. And it's because they use rice flour. So if you've ever overcooked rice to the point that it's like basically a big ball of rice, yeah, mochi is the same kind of thing. So you get this kind of like gelatinous substance, but it still has like properties of like the flour itself. So it'll fall apart a little bit. So neither of those things are quite a food gel, but they are pretty close. And you know, the reason why they gel up is because both of those have high polysaccharide counts inside of them. So they still have that polymer that you need for the food gel. So I talked a little bit about sodium alginates. Let me pause for a second. Is everyone cool with where we're at? Do you want me to move on? Do you have any questions, comments, concerns? All right. So, you know, we've gone through pectin, gelatin, agar, and like my brother said, gelatin and agar have pretty similar properties, and agar is a little bit more expensive when you find it in the store. So typically, if you go to a restaurant and you order something that is gelatinous, it's going to be made with gelatin. But if you're a vegetarian, you're going to find something that has agar in it. And a lot of Asian cultures will cook with both agar and gelatin, not necessarily in the same dish, but in, you know, several different dishes. I was actually just recently in Japan. I guess now it's not recently, it was like a year ago. And I had like the best dessert I ever had in my life. And it was like a fruit salad with ice cream, but they put these like agar cubes that were made with matcha green tea. And so they basically made green tea, added agar to it, let the agar gel kind of form, and then they sliced it into cubes, stuck it in with the ice cream, and then put fruit inside, and then there was some sugary syrup. And at that point, it didn't matter because it was just super delicious. And also super simple to replicate because, like I said, agar is flavorless. You can just, you know, you can use it to heat up whatever juice you want, and you have that flavored kind of gelatinous thing. So you can mix it with like a mango juice. I myself love pina coladas, and so like coconut and pineapple, you could do like pineapple and coconut cubes, mix them together, go crazy. You have a good time. Pour rum on that thing, you have like a edible pina colada. Now I'm just getting crazy. You guys got to stop. So the one last thing that we didn't talk about is sodium alginate. And I'll show you this video on YouTube I found. And this video, next adult night. This video that I have here is going to kind of walk you through the process of making sodium alginate gel. And like I said before, what happens here is like you mix your alginate with your, let's say it's a fruit-based thing. You can mix it with most kinds of liquids. The one I would avoid is orange juice, and there's a reason for that. But you mix it with your liquid, right, until you get a solution, and you really want to mix it in there like you would with the agar or the gelatin. You want it to dissolve. And then you do this really cool technique where you can put it into a syringe and you dip it, droplets of it into like a calcium chloride bath. And it instantly starts to polymerize from the outside in. And you want to really like scoop them up really quickly because you'll have like this really interesting like jelly exterior with like a fruity, juicy interior. So when you eat it, it kind of like pops in your mouth like boba, but more like Gushers, the fruit snack. So let me show you what I'm talking about real quick. So this is the, so he's filling, the solutions are already made, and right now they're filling the syringe with the sodium alginate fruit mixture. And you can see as soon as it hits the water, the gel starts to form immediately. So these droplets come out like little spheres, and they'll pull it out in just a second in like a spoon. But you really don't want it to sit any longer than 30 seconds because then the calcium in the bath starts to penetrate the gel and it becomes kind of salty. So you just rinse it off to get any excess calcium off of it. And then you can eat these things, and they'll sit in the gel for a couple of hours, but you really want to get them to the table quickly because there's still going to be a little bit of calcium residue on them and they'll just continue to gel. But if you really want that gusher sort of effect, pop them on the plate right away. And they're kind of cool. They look like little fruit caviar balls. They're kind of cool in like salads. You get like this really interesting texture. It's kind of cumbersome to make like a lot of it at a time. If you know, you saw at that one part that they had they had like a whole bunch of like pipette droppers going at the same time. So if you don't have access to that and you're doing it with like a single syringe, it'll take a little while to get a decent amount. So you'll just kind of get bored with it. But it's a really, really interesting thing. And so that process, if you just Google spherification, you'll find like all kinds of recipes on it. And the sodium alginate's a bit more expensive. It's like 20 bucks for, I think it's like half a kilogram of the materials. But it'll last you a while because you don't use a whole lot in your dishes. And then you just kind of, you know, use it in whatever kind of creative ways you want. Now, the reason why I mentioned earlier that orange juice is no good is because a lot of orange juices have calcium added to it to give you, you know, stronger bones. And so as soon as you mix the sodium alginate in there, it starts to gel and you end up with this like really gross gelatinous orange thing, which it probably tastes fine, but every time I've done it, it makes me want to gag. So Kevin asked if alcohol interferes with gel forming, and I haven't experienced that. There are different kinds of, so when you do the spherification process, you can do it two ways. One is the direct way, which I just showed you, and there's another way called reverse spherification. And for that, they actually do put alcohol in it. And the way the reverse spherification works is you actually have, like your liquid mixed with the calcium chloride kind of ahead of time, and you dip it into a bath of sodium alginate so a gel starts forming around your thing, and then you scoop it out and kind of freeze it. And by doing it that way, you basically only allow a thin layer of gel to form, and you can make bigger structures with this method. And so you can get kinds of presentations that are more like egg yolks on top of food, which is really cool. If you ever get the opportunity to go like a Michelin star restaurant, they'll use this sort of technique there. Quinn asks if you can use an agar bath with orange juice. Yeah, you can. So in that case, it's much better to use agar if you're using orange juice. If you want that, but you just won't get that like that gush of juice in the center. Yeah, reverse purification is how they made the bottleless water bottles. It's either that or there's another thing you can do, basically like the fruit leather method, where you can like do water mixed with agar and like lay it out really thin. I saw this one technique where if you get like a baking sheet, you can lay it out really thin on a baking sheet and then dehydrate that, or you could even like put it in the oven on super low temperature for a couple hours. So you dehydrate that so you get this really big kind of plastic film, and then you can just kind of like put it in a bowl. So you have your like, I don't have any, here's my water cup. You like put your, you know, your sheet on top of it and stuff it, and then you pour your liquid on top and then put another sheet on top of that. And then you kind of just like press and seal the sides. And now you have like a pouch of edible water bottle essentially. So you can drink your water and eat it too, which as Jason described, doesn't taste so great. That was really all I had for you guys. Happy to answer more questions. Yeah, Dave.
So it's really fun to hear this because we've been doing in the lab for a few years ago. We started growing algae in sodium alginate beads, and doing the same thing with make an algal solution and then drip it in there. And you can also, of course, if you squirt it around, you can make strings and all kinds of designs. But the most fun thing we ever had was that we had a guy, Paul Calvert, who was teaching a retired person down at New Mexico Tech, and he likes to 3D print stuff, and we basically made up an algal growth, or algae growing in a media, and put so much stuff into it to make it into a really like a paste, so you could actually squirt out the 3D printer, make it build up a structure, and then as it's printing, periodically spray it with the calcium solution with a little sprayer, and it would sort of solidify up, and you can build like little 3D live algal growing structures, you know. So we, which was just blew my mind.
That's crazy. So was it like the material that you put into the 3D printer, was it kind of hard like the plastics that we use, or?
No, you'd make it like a toothpaste. You put enough alginate in there to make it thick enough till it's like a toothpaste.
Okay. And
so it'll hold enough shape as it comes out. Then as you squirt it, it'll solidify in that shape before it oozes out.
So do you have a video of that?
We do. We printed out. We did it for we were doing some of that stuff for the National Science Foundation statewide grant. We were working on bioenergy and bioalgal stuff, and we used it to print out EPSCOR, which was the name of the the grant program.
I'm gonna have to add that to the interview that we did earlier. The little blurb.
I mean, one thing we looked at. One thing we looked at, my student was really interested in this idea of using it in food, my PhD student, you know, and it found something about making margaritas with them, and he ended up, I think, not realizing the stuff you're talking about for, you know, maybe doing it really quickly, and he said it was like a really salty, not so good margarita. So I just think he did it right. I think I've learned this. I haven't watched this and try it again.
Now you're onto something. If it's so salty, you can put this like wormy thing around the rim, and you have this like edible salt rim.
Right. But I've also been interested on you know, trying to get this stuff. We were working on proposals for astronaut food to make things more interesting, because right, people have eaten some sorts of algae, right? You can get spirulina or whatever, and there's complaints about it not tasting good. And so we started to work a little bit a couple years ago, or a year or so ago, on a proposal to say, look, you know, let's go to the culinary folks that use this stuff in interesting ways and have them tell us how to make the spirulina taste good in the alginate beads, and have some interesting textures and stuff that the astronauts could eat on the space.
My brother is happy.
Yeah.
You're breaking out just
Is
a
he
little.
close to Cape Canaveral?
Actually, he isn't too far from there.
Ah.
He's in Jacksonville.
All right, I should hook him up with the folks there that are interested in this kind of stuff.
And then they send us videos
Yeah.
how we can make everything into alcohol, apparently.
Yeah, right.
I mean, it's for science, right?
Right.
Mhm.
Well, it sounds like we have a lot of new science to do while we're all stuck at home, right? Make little balls of things. Like, I'm sure Amazon delivers that, right? Right, Anthony? You can get that online?
Yeah, you can buy the sodium alginate on Amazon, and I'm sure you can get agar on there too. You'll probably find them in bigger quantities, like half kilogram size portions, which would be like 1 or 2 pounds. And when you have like a pound of sodium alginate, you basically have like a lifetime supply, unless you are in an industrial kitchen or a bio lab. Quinn asked what are some of the more creative applications for gelling agents that I've seen, and I would say the edible food pouches are probably the most creative. And then, like I said, the Michelin star restaurants are always doing the weird stuff. So, like the reverse purification, I've seen they make that like, and they'll use like a mango sauce kind of thing and put it on top of something, but it looks just like an egg because of the color. And you pop that on your food and you have this like oozing texture that's really pleasing. But then also you can do like alcoholic drinks that are like these little pods that you just stick in your mouth. So it's like the Tide Pod challenge that actually doesn't kill you. DC gelling agents used by Michelin star restaurants when making food-based foams. So the foams are different because it's aerosolizing, and you still need to create a structure in there, but they usually have these like canisters that they mix their materials in, and they'll have it with like a cream or something like that. So you spray it, and so like all the aerosolization happens inside the canister, and it comes out as like a foam. And Dave asked, how many Voltron generations are on that shelf? And there's actually only a couple. So we have OG Voltron made out of Legos in the back. And this is the Voltron from the Netflix series, which I highly encourage everybody to watch because it's really good.
Speaking of Netflix plugs, the Final Table on Netflix is a cooking show, and they got all that kind of fancy crap where they do like gel stuff. So you can feel like, yeah, I know what they're doing. I could win this show.
Yeah, I forget the gentleman's name. It's like Dave something, but he's
The
from
Michelin guy?
what was that?
The Michelin star guy?
No, well, he is a Michelin star guy, but there's like the Final Table, and then he does a couple of other shows, Chef's Table, and there was one other thing that he did. But he does a couple episodes around like food gels and foam-based stuff, which is really interesting. There's like a whole episode on eggs, which is really fascinating too.